Good evening and welcome to tonight's virtual open house. My name is Kelsey Perry and I'm Mayflower Wind's Community Liaison Officer based here on Cape Cod, and I will be moderating tonight's event. First and foremost, I'd like to thank you all for taking the time out of your evening to join us tonight and to learn more about the Mayflower Wind project and our activities in Falmouth. We'd also like to acknowledge the state representatives and town officials that are here with us this evening. Thank you for joining us. Tonight, we'll be giving you a virtual 3D tour of our Falmouth project from the offshore lease area to the onshore facilities. This is the third event in our open house series titled The Future of Clean Energy is Here. We had over 200 registrants for tonight's event, most of you coming from the Falmouth area, and we're grateful for such a great turnout. Here is tonight's agenda. First, we will give you a high-level overview of offshore wind development on the east coast of the United States and an overview of the regional electrical grid here in Massachusetts in order to contextualize Mayflower's project and the larger systems at play. We will then dive into our virtual tour of the Mayflower project, including the offshore and onshore components. And there will be 3 stops along the way to ask questions. Here are tonight's speakers. As mentioned, I will be moderating. We have Chris Hardy, our external outreach manager, who will be our main speaker and tour guide tonight. We have our new community liaison, Dugan Becker, who will be driving the 3D tool behind the scenes. And we brought in some of our internal experts to participate in the question and answer section this evening. We have Joel Southall, our fisheries liaison officer, Kelly Smith, our onshore engineering lead, and Tim Ryer, our export cable and inter-array cable lead. And with that, I'll now hand it over to my colleague, Chris, to kick off the presentation.
Thank you, Kelsey. Good evening. I'm Chris Hardy. Many of you who have registered tonight, as well as at our previous public meetings, have asked questions that entail broad principles and specific details about the project. Tonight, we aim to answer those questions and those principles through this tour. I hope you can help settle in and get ready for an evening of learning with a lot of information to absorb. Let's start with the grid, though in the actual project sense, it's the end of the tour. The New England grid is in transition. Think of the grid as a complex system that's designed to match various sources of supply with changing demand. Inflows must equal outflows to maintain system frequency, and additional supply is dispatched if a single project is unable to meet its actual capacity. The transition to net zero calls for new generation to power the emerging electrification of our heating and transportation sectors while supplementing the fossil fuel and nuclear power plants that are being retired across the region. Since 2015, the New England states have solicited 7,000 megawatts of new supply, primarily offshore wind and hydrogen. At the same time, almost 7,000 megawatts of older plants, mostly coal, oil, or nuclear, have announced retirements or soon are about to. One example is nearby Falmouth Heights Beach, the 1,200 megawatt canal generating plant, which operates on oil and natural gas and is therefore among those subject to future retirements. Offshore wind will offset the need for imported fossil fuels and enhance the limited energy supply mix that's available to serve the electric load on Cape Cod and southeastern Massachusetts. Offshore wind provides a stable, cost-competitive price while helping to achieve reliability, environmental, and economic development goals. The New England states and New York have procured almost over 9,000 megawatts of offshore wind under competitive auctions so far. The projects that have earned these power purchase agreements are located in the stack of offshore lease areas shown in the map in the middle. There's 7 active lease areas and 4 different sets of joint venture owners. Each leaseholder seeks to maximize the generation capacity of their individual lease area while minimizing impacts and costs. The megawatts of electricity that are generated by each of these offshore lease areas is included within the regional grid energy supply mix that's managed by the regional grid operator. Each leaseholder bears the sole risk and responsibility for delivering power to a point of grid interconnection known as the point of interconnection, or POI. Those points are marked as the orange circles at the end of the blue lines shown on the map. The independent system operator enforces a single source contingency rule that limits the capacity of a single project at a single point of interconnection to no more than 1,200 megawatts. In addition to this rule, existing conditions limit how much energy can be injected at a single point of grid without specific system upgrades. The Cape Cod and southeastern Massachusetts region are located at the end of the regional transmission grid. The amount of power that can be transmitted across Cape Cod is limited by a single line extending across Cape Cod Canal. The independent system operators' modeling results indicate that as more offshore wind is brought into the system, less energy will be needed from within the regional grid to serve the southeastern Massachusetts load, relieving some of the congestions in the network that impede further development now. Unfortunately, though, due to the single source contingency rule and other factors related to the costs and benefits of coordinated transmission systems, each developer will be pursuing multiple paths of export to different points of interconnection on the grid in order to fill the full generation capacity of their lease area. Through a grid connection in Falmouth, Mayflower Wind will help diversify the energy supply mix in the Cape Cod and southeastern Massachusetts region. As a generator, Mayflower Wind is responsible for the generation and delivery of 1,200 megawatts to the Falmouth point of interconnection. Eversource will be responsible for the construction and operation, for the construction and operation of the Falmouth grid interconnection. And from there, an interconnected network of transmission and delivery lines will ultimately deliver power to you, the customer. Tonight, with the use of a three-dimensional visualization software using animated sequences, we aim to provide a different look at the Mayflower Wind project. We hope it will enable you to think about Mayflower Wind in a new way. Let's head off. Looking down as though from a satellite, the offshore lease area, which has the capacity to serve nearly 1 million homes, is located over 30 miles south of Martha's Vineyard and 20 miles south of Nantucket. The project will occupy the entire 199 square mile offshore lease area, which was awarded through an auction made by the United States Bureau of Offshore Energy Management. By pursuing dual delivery points, delivering 1,200 megawatts to Falmouth through the northern route and 1,200 megawatts to Brayton Point to the northwest route, Mayflower Wind can maximize the generation capacity of the full lease area. Now, as we zoom in a little bit closer, we're looking at the site layout for the offshore wind farm. And the site layout for an offshore wind farm takes into account a number of different factors, including the seafloor conditions and navigation safety. Obstructions, the seafloor shape, shipwrecks, and other elements have an impact on the placement of specific project facilities. What you're looking at here is the lease area with its 149 positions for the wind turbines and offshore substation platforms modeled. Mayflower Wind and the other New England offshore leaseholders worked on a collaborative layout for the wind turbines across all of the lease area boundaries. This layout creates more distance for navigational lanes than any offshore wind projects in the world, creating more than 200 transit lanes in all different directions throughout the offshore lease area. the United States Coast Guard determined in its 2020 study that through this, safe navigation can be maintained across 7 offshore lease areas, covering over 1,400 square miles of the ocean. Now, fishing and boating activities can continue as permitted in the project area, though there can be some temporary exclusion areas anticipated during construction. The water depths, interestingly enough, in relation to the mean lower low water level, range from about 120 to 200 feet deep. Let's take a closer look at the wind turbines, which convert kinetic energy from the wind into electric power. Mayflower Wind is looking at different wind turbines based on the available technology and the feasibility for the project. And there are definite trade-offs. As the generators increase with larger rotor diameters to yield more power, they require larger foundations to accommodate their size. And the turbines that you can see modeled here and in our analysis for the project have blade lengths that are about a football field long and have hub heights that are 1 to 2 football fields long in terms of height above mean lower low water. To help reduce light at night in alerting incoming air traffic, Mayflower Wind will utilize an air traffic detection lighting system that reduces the light activation by 99% compared to the traditional always-on lighting system that's used. Another interesting question that's often asked about is what precautions have been taken to design the wind turbines in the context of hurricanes and other extreme weather events. And the wind turbine design practice has incorporated decades of experience from the use of offshore oil and gas platforms in areas like the Gulf of Mexico that have experience with significant hurricanes, turbines that have survived typhoons in Asia, and the cold weather technology that enables turbines to survive even at the U.S. research station in Antarctica, are part of the combined best practices that are going to be utilized in the turbines for the Mayflower Wind project. Supporting the wind turbines are the foundations and the substructures. Mayflower Wind is considering 4 substructure options, including monopiles, pile jackets, suction bucket jackets, and gravity-based structures. And depending on the substructure option that's selected, the burial depth of the foundation could be up to 295 feet below the seabed. Shown here are the monopile and the jacket substructure option. These are the 2 of the 3 that would require burial depth. The gravity-based structure would not. Now let's visit the offshore substation platform. Now, for the ease of the demonstration in the model, it's located outside of the lease area, but in the actual project, it's located within the boundaries of the lease area. The platform serves several different critical functions. It's first the collection and termination point for the inter-array cable system that connects each of those individual turbines to each other and then to the platform here, operating at a voltage of up to 69 kilovolts. The offshore substation steps up the voltage to 275 to 345 kilovolts, or for export to the onshore substation. Now you might be wondering how tall these are. They're about half as tall as the wind turbines, or about 161 to 345 feet above mean lower low water level. And finally, the offshore substation platform is the starting point for the export cable routes that will take the power to the onshore substation. So let's take a look at the export cable corridor that goes north to Falmouth, and as you can see here, first northwest to Brayton Point. The route to Falmouth was developed to avoid existing marine infrastructure, including navigation channels, ordnance disposal sites, anchorage areas, and existing or planned marine cables. Expected cable distance to Falmouth is between 52 to 87 miles. There will be up to 3 submarine cables and up to 1 telecommunication cable within this corridor. The cable corridor will be between 2,600 and 3,300 feet, or about a half a mile, to enable maneuverability during the installation process. The proposed cable depth is 6 feet below the level seabed. Each cable will be separated by about 328 feet, varying though based on the bathymetry. Now, in terms of the technology, Mayflower Wind's preferred technology is the high voltage alternating current, or HVAC system, though we're also evaluating high voltage direct current technology, or HVDC, which has less power loss over long distance typically. However, it's traditionally more costly and has more limited supply chain options. Now, the engineers that have looked at both technologies typically have assessed it and considered that a range between 60 to 75 miles is a typical point at which HVDC is a better choice. For that reason, HVDC will be used for the Brayton Point project that we can see shown to the west of Brayton Point, while HVAC is the preferred technology for Falmouth. Now, I know most of you have come to talk tonight about the landfall and the onshore and the route to the substation. We're going to take a brief break. I think we all need, including the speaker here tonight, and have some questions about what you've seen tonight regarding the offshore area, and introduce our colleagues for some questions regarding that.
Great, thank you, Chris. The first question that we have this evening is for Joel, our Fisheries Liaison Officer. So Joel, this first question is, how will Mayflower Wind avoid conflicts with other harbor users due to the increased vessel use in the lease area?
Yeah, thank you very much for that, Kelsey. I really appreciate that question, because it's a really important question. And one of the things to point out first is that that Mayflower and that all of the other offshore wind developments in the Mass Rhode Island wind energy area that Chris was talking about are being developed in a way where existing uses will be able to continue in the way that they did before. So then in terms of being able to communicate, collaborate, coordinate with other harbor users, we already have a lot of information on our website about some of the surveys that we've been conducting, issuing notice to mariners, doing outreach events, and have found that constant early communication of that information is really important for that. And we will continue to do that going forward as we go from the permitting stage, so the survey stage, into construction and eventually operation.
Perfect. Thanks, Joel. Here's another question for you. What is the reliability of the turbines in cold weather?
Yeah, thank you. Definitely a topic for the week, since it's been a cold start to March. And Chris actually touched on that a little bit earlier, and I'll definitely follow up on that. So, Chris referenced that the fact that there are wind turbines in Antarctica, and there are some wind turbines that are in some very extreme cold environments. And one of the really interesting parts about that is that the design and the way that they are sort of developed, installed, maintained can really match the conditions as well, including some very, very cold conditions. So there's a lot of work that's ongoing about the way that coatings can be applied. We're in the process of looking at what the turbines for Mayflower will eventually look like. And a big part of that is being able to match the conditions where they'll be installed and operated. So a lot of good history of the wind industry installing, operating turbines in very cold, extreme environments for a long time, and Mayflower will continue that.
Awesome. Thanks, Joel. One more quick one for you, and then I have a couple for Tim. So what is the distance between each of the turbines in this demonstration?
Yeah, thank you for that. I'm really glad that we have this 3D tool now so that we can actually see that. And the spacing there that Chris was talking about, the furthest spacing regime of any area in the world. So it's a nautical mile from that. So now we're looking north. So from east to west, it's a nautical mile. And then from north to south between the rows and the columns, it's all a nautical mile in between those.
Great. Thanks, Joel. And here's a quick one for Tim, our export and interarray cable lead. Tim, how many offshore substations will there be?
Thank you for that question. We will have up to 5 offshore substations. The offshore substation serves many functions, as Chris mentioned. So collects and it's a collection and termination point for the interarray cables, and it also delivers power at the export voltage, so it increases the power as it's sent to shore. And we'll have up to 4 offshore substation platforms of one of several designs.
Perfect. Thank you, Tim. And here's another one for you. So is Mayflower, as of right now, planning any battery storage?
Yeah, thank you for that question as well. Not at this time. So Mayflower Wind recognizes that battery storage is an exciting technology and it can have significant economic and environmental benefits. However, our analysis does indicate that dedicated storage facilities physically located closest to load sources, so that matching needed durations in areas such as urban neighborhoods, institutional campuses, better support peak needs rather than storage systems that are co-located with offshore wind projects. So not at this time.
Perfect. Thanks, Tim. And here's another quick one. What is Mayflower Wind's maximum capacity?
Sure. So the maximum capacity of the Mayflower Wind lease area is greater than 2,000 megawatts. So enough, I believe, as Chris mentioned, to power approximately a million homes or more. And the approximate capacity of the Falmouth project is 1,200 megawatts.
Great. Thank you, Tim. Here's an interesting one for Joel. And we only have time for 1 or 2 more questions in this section. So for Joel, will each turbine structure broadcast its location onto an AIS channel so that shipping can find all the structures without depending on radar for that purpose?
Yeah, thank you for that. So one of the things that Chris also mentioned is a benefit of the regular 1x1 grid is predictability. So before you even get to AIS, which is a system that lets you sort of see where things like boats or potentially wind turbines are, before you even get to that, the predictability of the 1x1 grid really has a big benefit for navigational safety. In terms of AIS, there's a variety of options that are being looked at, including AIS signal, virtual AIS, where the turbines would show up just as an AIS signal from a ship or something like that.
Okay, thanks so much, Joel. And that's all we have time for in this section, but there will be 2 more opportunities to ask questions. So back to you, Chris, for the next part of our tour.
Thanks for the questions and thanks for speaking with us, Joel and Tim. We're going to now move on ahead to the landfall and the onshore work. As we look at the shoreline, we want to look at the routing alternatives that Mayflower Wind considered. And it involved several different criteria involving construction impacts, the length of the proposed route, traffic congestion, land use, environmental justice, population impacts. And it was quite an exhaustive assessment that included more than 10 different grid interconnection options, 16 potential substation locations, 12 landfall locations, including 7 in Falmouth, more than 20 onshore cable route options, and 5 different offshore cable route options. Locations along Surf Drive Beach were intensively studied, but proved ultimately infeasible due to the technical issues created by the existing utility power cables extending to Martha's Vineyard. For the preferred alternative site, landfall location is at the first block at Worcester Park along the 2 lanes in Worcester Avenue. For the alternative, landfall is at Central Park near Crescent Avenue. And you can see those in the indicative circles. Those aren't obviously the exact areas of the project. The Worcester Park landfall has only a slight elevation change, which makes it an ideal candidate for horizontal directional drilling, which is a trenchless process that would begin about a half a mile from the beach itself to enable minimizing and avoiding impacts to the nearshore eelgrass beds. Each of the 3 proposed cables will have its own trajectory and each cable will be up to about a mile in length at a depth of between 40 to 70 feet below the beach. We're about to watch an indicative drilling sequence that would occur at either Worcester or Central Park. This is the preparation process. And now we're watching the sound wall being erected around the onshore entry site for the HDD. And that's being done to minimize the construction noise impacts. And the site is now a drilling rig is drilling a pilot hole under the seabed. "40 to 70 feet below. It's now supported by a barge offshore. The duct, the conduit, is made of high density polyethylene or plastic piping. It's being pulled, followed by the cable. The 3 offshore cables connect to onshore cables in a transition vault at the landfall site. Now, to deliver this amount of power, there'll be 3 circuits. Each circuit consists of 3 cables, 1 per phase, for up to 9 power cables in total. All that will be visible will be a series of manhole covers. Mayflower Wind will restore the park location to a condition as good, if not better, than when construction started. And we're about to show you from here is just the indicative path for the onshore cable route to the onshore substation locations. Before we take that journey, we're going to take a pause here and answer questions about the HDD process and the impacts to the landfall sites, as we've shown here tonight. We look forward to your questions.
Great, thank you, Chris. The first question we have is a quick one for Tim. So Tim, can you just reiterate how deep these cables will be after the HDD installation? And again, the demonstration is only showing 1 cable. Will there be 5 of these cables?
Thank you for that question. So the depth of the cables will be up to approximately 90 feet total. And as Chris mentioned, about 40 to 70 feet below the beach. So deep enough to maintain stable burial and make sure that the cables avoid impacts to nearshore and sensitive beach areas. And we plan to install up to 3 power cables and up to 1 telecommunications cable for a total of 4 cables. Which will all be making landfall.
Thanks, Tim. Here's one for Kelly. So why does the undersea cable take a hard left after Martha's Vineyard instead of going straight to Mashpee or Barnstable? Maybe you can speak to some of our analysis done on our landfall location selection.
Sure, thanks for the question. I'm happy to speak to the onshore decision making there, and then maybe I'll pass it to Tim to chime in on the offshore export cable route. But in terms of selecting our route options to make landfall, it really starts with an analysis of the regional transmission grid. So Mayflower took a hard look, as Chris mentioned, at a lot of locations that could offer an opportunity to interconnect the grid, and found Falmouth to be an optimal point of interconnection. And then from there, it's a matter of figuring out the routing analysis where it's appropriate to make landfall and balance environmental concerns, community concerns, environmental justice concerns, and the overall length of the route. Tim, do you have anything to add there?
Yeah, thank you, Kelly. I believe you covered it well, but on the offshore side, we also assess such factors as impacts to the seabed, environmental sensitivity of the routes that are considered, and also existing infrastructure, including existing and planned submarine cables in the area when deciding on the route that we proposed.
Perfect. Thanks both for that tag team. Here's another one for Kelly. So why can't Mayflower just use a DC line and use that DC line to go up to Bourne or Plymouth or Brayton Point on the other side of the bridge and work to co-locate our cables? What is the reason for 2 landfall locations?
Thanks. That's actually, yeah, that's a really good question. So the reason Mayflower has proposed 2 interconnection projects to deliver the full potential of our lease area, it ties back to what Chris was talking about earlier, the fact that ISO New England, the regional grid operator, has a policy, it's a single source contingency limit. And so for reliability reasons, the amount of power that can go down a single line to a single point of interconnection is limited to 1,200 megawatts. So Mayflower is looking to maximize our lease area by proposing 2 interconnection projects.
Great, thanks for that clarity, Kelly. Here's another one for you. So how long will this construction work take at Worcester Park?
Sure, I can speak a bit to the overall onshore construction. And so for the route that Chris is about to show in a bit more detail, which goes from Worcester Court up, takes a left onto Jones Road and then heads up Gifford Street. It's about 2 miles long. We anticipate that work would take about 2 years to complete. And Mayflower would look to complete that work in the off-season, the off-tourism season, because we do understand there are concerns about traffic and use of these spaces.
Perfect. Thanks, Kelly. And here's one for Tim. So can you clarify, will Mayflower during the HDD installation process be using the nearby paved parking lot at Falmouth Heights Beach or actually using Falmouth Heights Beach?
Yes, thank you for that question. So we will, during the construction, plan to use the parking lot nearby Falmouth Heights Beach for staging of equipment during the HDD operation. Yes.
Perfect. Thanks, Tim. Here is one for Kelly. What will be the measured decibel levels of all of the machines running when this construction is happening? And what hours are we going to try to stay within during this construction process?
Thanks, Kelsey. That's another really good question. So Mayflower will coordinate with the town of Falmouth and work to collaborate with the Department of Public Works around construction hours. We do appreciate and understand the fact that this sort of construction and underground installation does involve your standard civil equipment that does produce noise. And so we would look to manage that by introducing, there's technology that can muffle some of the equipment, and also you can introduce enclosures for some of the equipment that's running all of the time. Another thing to keep in mind here is that the installation of the onshore route is going to be a moving progression. And so only about 20 to 200 feet would be worked on at one time. So the construction related noise impacts would be temporary. If you're interested in getting a full sense of what construction related noise could look like, we do have a complete study on Mayflower's website on the documents page, and it gets into the details about decibel levels.
Great, thanks, Kelly. Unfortunately, that's all we have time for in this section. I just want to make a small comment on how we're planning to handle these questions. We are getting a lot of questions tonight, and we're trying our best to answer as many as we can. If we do not get to your question and we don't address it live, I do encourage you to follow up with us at info@mayflowerwind.com, or we'll try our best to get back to you after tonight's event. There will be one more opportunity to ask questions after this last segment of the tour. So back to you, Chris.
Thank you. All right. Well, now let's follow the route to the onshore substations. Both of the routes from either of the landfall locations are located at existing aggregate processing facilities. While most high voltage transmission lines are located or consist of overhead lines, a growing number in America are underground, including most recently the Woburn to Wakefield line, which operates at a voltage of 345 kilovolts, which is the standard bulk transmission that operates in the New England grid, and will be the voltage that this project will be operating potentially up to in matching. The onshore cable route will be primarily installed within the existing paved roadways or roadside shoulders using open trench installation. We've now reached, well, we were looking approximately closely at the onshore substation at the preferred site, the Lawrence Lynch site, and we're now about to see an installation sequence for the trench. The lane or road closures would be installed, as Kelly had mentioned, using a rolling setup. So only a section of the roadway is actually being worked on at a given time. And the excavator, the backhoe, is digging the trench. The trench is dug to a depth of about 8 feet deep. And their support structures. After the trench is dug, the backfill is filled in, the cable conduit is laid, ducts are laid, segments of plastic pipe are what the ducts consist of. They're encased in concrete. The backfill is filled and then covered in repaved. Here the cables are coming into the transition fault, or splice fault rather, which are every third to half mile. That was a quick open trench installation sequence. Each vault is approximately 30 feet long, 8 feet wide, and it's dug at a depth of about 13 feet. This is showing just an overhead view of the substation site. It's currently used as an aggregate processing and asphalt facility, and it was selected as the preferred substation site because it's closest to the landfall site, limiting the length of the underground cabling, which decreases the costs and lessens the impacts on the traffic and the duration of the construction period. The onshore export cables would enter the substation in the southeast corner of the yard. This is showing you an indicative substation layout. The substation itself is expected to occupy between 10 to 17 acres. Let's look at the approximate distance to the Woodbriar facility, which is a residential community. We can see that's 175 meters or about 575 feet. Now, to take a closer look at the substation yard itself and the equipment that's inside, let's take a closer look at the alternative site, just for the sake of time, as the substation layouts at this point in time are pretty much the same. Now, the alternative site location is at Cape Cod Aggregates, which is also an aggregate facility. The project is looking to take use of existing disturbed areas to minimize the overall impact. The onshore cables would enter in the southeast corner, and then a 345 kilovolt transmission line would extend along the existing overhead utility line that's shown to the west. This is also a view of an indicative substation layout, also of about 10 to 17 acres. And as you can see, the vegetation around the Cape Cod aggregate site creates a buffer around it. Let's take a look at the closest distance to the nearest structure. And that's about 130 meters, which I believe is 425 feet. Let's take a look as if you were walking along the road. See what the substation might look like. You can see foliage at different seasons create a different view shed. To the left, obviously, is the substation yard as we're walking along the road. Now let's take a closer look at what's actually inside the substation. Okay, the major components include air-insulated circuit breakers, switchgear, and transformers. And the substation does contain sound-producing equipment during operation, whereas the cables do not produce noise during operation while there's noise during their construction. As the substation equipment itself and the layout is further refined, Mayflower will also refine our mitigation strategies, which include enclosures of certain substation components, the use of low noise transformers, sound barriers, and again, the vegetation itself acts as a proven noise and visual mitigation. One of the interesting things about is that we'll also look at is outdoor lighting, though not in the model itself, but amongst the mitigation strategies to minimize the amount of light that might encroach beyond the substation. We'll be using LED type fixtures that have shields that prevent that from occurring. And so lights would only really actually be used in emergency situations. So there'll be minimal light impact, as it were. And also, due to the somewhat routine nature of the substation work, there'll be no need for personnel on site. This will be an unmanned site. Operations and maintenance personnel will visit the substation and perform their routine maintenance and inspections according to a regular schedule. Great. We're now going to venture off to the final point of the tour. And from either of those substation sites, Mayflower Wind, as I've mentioned before, will interconnect to a point of interconnection utilizing an overhead transmission line along the existing utility line to reduce the amount of underground cable in public roadways to reach what's known as Falmouth Tap, which is an existing substation that's owned and operated by Eversource. That substation will be upgraded to accommodate the Mayflower Wind project. The Falmouth grid tap connection enables Mayflower to access the existing 345 kilovolt transmission system line that runs across Cape Cod Canal, extending from Barnstable to Carver and Plymouth, in an interconnected network of 345 and 115 kilovolt transmission and distribution lines ultimately deliver electricity to regional customers across New England. This ends the virtual tour of the offshore to onshore connection. And we're going to stop here and answer some of your final questions.
Great, thank you, Chris. This first question is for Kelly, and it's a question that we get frequently, and we've received it multiple times in the Q&A chat, and we're going to address it now. So what are the EMF levels above the buried cable banks, and how will the public be protected from these EMFs onshore?
Thank you for the question, and we do understand that this is an important one for the community. So EMF stands for electric magnetic fields, and they are produced by natural and man-made sources and come in relation to all electrically run appliances and anything related to electric infrastructure. So they have been studied extensively over the decades, and after 40 plus years of investigation, there's nothing conclusively connecting these fields to anything that has warranted a push for a public health regulation on them. There is a standard from an international agency that points to 2000 milligauss as a recommended limit for EMF fields. And I can tell you that Mayflower has done a full study of our system proposed and shown today, and our predicted levels are well below that, even using conservative inputs for the modeling effort. So if you want to have a look at that, that's another one that I'll point you to our website for the full technical report done by our EMF experts.
Thanks, Kelly. Here is another one for you. What is the life expectancy of the cable jacketing?
Sorry, I originally processed that as an offshore question, but the cable jacketing onshore, we're assuming that the onshore infrastructure will have a life expectancy of at least 30 years, but that's to basically align with our offshore assumptions. But we understand also that onshore electrical infrastructure is typically in place much longer. So I would say that the onshore infrastructure likely to last 50 plus years, although it'll really depend on material and installation methods to be decided on later.
Thanks, Kelly. Here's a quick one for Tim. How long will Mayflower have equipment at Falmouth Heights Beach parking lot?
That's a good question. Thank you. So we plan for the HDD operations activities that are taking place at the parking lot in question to last approximately 2 to 3 months, and to plan those activities outside of tourist season. So within the months of October to May. Thank you.
Thanks, Tim. Here's a quick question for Kelly about the trenching. Actually, maybe Dugan, you can go back to that. So where does the open trench begin and the trenchless end?
Sure, so the horizontal directional drilling is a trenchless installation method, and that ends in the first, for the first example we showed in the demonstration, the first block of Worcester Park. So that would be the end of the trenchless installation method that we're proposing. And then the rest of the route would be an open trench installation in public roadway, similar to other types of underground utility work that you've seen in the past.
Great, thanks, Kelly, and thanks for showing that again, Dugan. Here's another one for you, Kelly. How long do we anticipate the full onshore construction process to take? So from the HDD installation all the way to Falmouth Tap, as Chris showed.
Sure, so I think Tim already touched upon the duration for the HDD construction. For the onshore segment from the landfall to the first substation location, we're assuming approximately 2 years. Again, that sequencing would have to be refined, and the work windows would have to be developed in collaboration with the local community. And then from there, the duration of time it takes to interconnect all the way to the Falmouth Tap substation depends a bit on whether that interconnection is done in the existing utility right of way or whether it's done in roadway. But we're estimating a rate of installation progress in roadway at about 20 to 200 feet per day, depending on how many existing utilities and other constraints are found in the roadway.
Great, thanks, Kelly. Here's one about the substation sites and the our relationship and agreement with the landlords. So are these property owners selling or leasing these 10 to 17 acres?
That's a good question as well. So we have had ongoing and positive dialogues with the landowners of both of these facilities. For the first one that was shown, the Lawrence Lynch location, we don't currently have an agreement in place. We've identified it as a promising site. And I know at this point in time, the owner has no plans to relocate his asphalt processing and other activities. And the substation footprint that we showed in the visual is the upper end of the range that we described tonight. So again, future evaluation will have to be done to determine exactly what pieces of electrical equipment we need, what the exact substation technology is, and whether co-location is a possibility.
Great, thanks, Kelly. Here's one for Tim, and this is a specific question, but may result in kind of a broader answer. So we stated that the cables will be 6 feet below the seabed and about 8 feet below the roadways. Yet, we also stated that the cables would be 40 to 70 feet below the beach. Why is this necessary, and how is this actually going to be achieved? Maybe you can kind of just speak to you know, why we're making these decisions about the depths in these different areas for the cables.
Yeah, that's a very good question. So I'll start from offshore and go onshore. So we assess carefully the burial depth that's required for the further offshore portion of the cable to ensure that the cables stay buried. And all you see is the seabed on the seabed as if you were flying over this offshore, right? As we get closer to the beach, the marine environment, and as you come on shore, really close to shore, can become more sensitive and more dynamic. So we employ the horizontal directional drilling technology that we've described before and that Chris gave an overview of to bury the cables deeper beneath the beach, which really allows you to maintain stable burial and also avoid impacts to the sensitive nearshore resources on the beach. And then once we have the cable, stably buried underneath the beach to avoid those impacts, it comes ashore, and then the burial depth onshore is also carefully considered in alignment with typical utility construction practices and what you would typically expect for underground utility construction in these areas. Yeah.
Great. Thanks, Tim. Here's a quick question. I may be the best to take this one, so I will just answer it. So what do we mean by environmental justice? Environmental justice communities are areas designated by the state of Massachusetts that are usually either identified as low income, English isolated communities, communities who their primary language is not English, minority communities, and basically we take these different types of communities into account to make sure that we're not causing any more impacts that need to happen to those specific communities, the underserved communities. Here is another question for Kelly. So the question is, what are our emergency provisions? Maybe you can just speak to some of our health and safety requirements around these activities and what we would do in case of an emergency.
Sure, great question. So both of the sponsor companies behind this project, Shell and Ocean Winds, have a strong history of prioritizing health and safety. So that would certainly be a priority for all phases of the project. For the current phase that we're looking at today, it is just reflective of preliminary design efforts. So it's a bit early to speak to very concise, clear elements of a health and safety plan, but we would certainly develop a health and safety plan for all aspects.
Perfect. Thanks, Kelly. Here's a quick one. Is there any plan to design and implement microgrids in Falmouth to increase energy resiliency for the various neighborhoods? And maybe you can speak to how offshore wind enhances reliability inherently.
Sure. So no plans at present to develop microgrids. This is an offshore wind focused project, but anything that can be done to increase the supply of energy to the grid and vary the points of interconnection contributes to overall reliability, which is a good thing for the system.
Perfect. Thanks, Kelly. And here is one about trees. So will we be able to plant any trees over the transition vaults or the duct planks? And if we can't plant those trees over them, how close are we able to replant them?
That's a good question. So it's not recommended to plant vegetation with deep root systems right on top of underground concrete installations, because over time, those roots can infiltrate and crack into the concrete. A typical rule of thumb is that the root system is approximately the same area as the shade. So that's produced by the final growth. So it would be something that would have to be looked at in detail, but in general, you could cite maybe something nearby, but not directly over top. And it would depend on the type of tree.
Awesome. Thanks, Kelly. And as it's 7:27, I'm going to move along to our last question. And this is for Kelly again. So is there any benefit to Falmouth in this project, or is this energy just traveling right through the town to the grid?
Thanks. Yes. So the town of Falmouth would benefit by hosting a large clean energy interconnection project. Mayflower is also working on a host community agreement in collaboration with the town, which would offer consistent revenue through the duration of operation, which could be used at town discretion to fund all sorts of programs, could be related to clean energy, climate change resilience, really all sorts of programs. Over the lifetime, oh, go ahead, Chris.
I'm sorry, keep going.
Oh, I was just going to add that over the lifetime of the project, there would also be occasional maintenance activities, and particularly during the construction itself, there would be a need for local contractors, and that would contribute to the overall business as well.
On the question of power supply to Falmouth, I wanted to just point out, and I apologize for cutting in there, Kelly, to make a note about the efforts of Representative Fernandez at the State House to enable organizations like the Cape Light Compact to enter into long-term offshore wind agreements utilizing backstop authority from Mass CEC, which is a critical organizer and enabler and partner in the offshore wind industry here in Massachusetts. And so Mayflower Wind has been supporting Representative Fernandez and other members of the Cape delegation in addressing this need to empower communities like Falmouth and other members of the Cape Light Compact in being able to further green their local supply through municipal aggregation opportunities, green aggregation as it's sometimes referred to, via this type of new authority. And so we applaud Representative Fernandez and the others for their efforts.
Great, thanks, Chris. And with that, it is 7:30. We are out of time. My apologies if we didn't get to your question tonight. We did receive a lot of questions. Please feel free to email us any follow-up questions to info@mayflowerwind.com or call the number on the screen. We will try to respond to the emails that you sent to us tonight. I want to note what's up next for the Falmouth project. We do have a Massachusetts EFSB siting board public comment hearing coming up on March 24th. So please stay tuned for that. We will be sending out more notifications about it. We'd also like to urge all of you to follow our social media pages displayed here, as well as subscribe to our newsletter to stay informed about the project and any future events like this one. From all of us at Mayflower Wind, we would like to thank you again for joining us this evening, and we hope to see you all again soon. Thank you.